Welcome to Module 5 of Middle School Mathematics Praxis Prep. In this module, we'll be discussing probability, statistics, and discrete mathematics. This course is a partnership with TLC Tutoring Company and Arkansas State University. Now, data is one of the most powerful tools we have at our disposal for scientific analysis, but the information needs to be represented in a way that the conclusions can be effectively reached and communicated. So, some common analysis tools that we're going to review in this section are the box plot, histograms, scatter plots, stem and leaf plots, and among others. First of all, we're going to start with the box and whisker plot, also just called a box plot. It displays the 5-number summary of a set of data. So the 5-number summary is the minimum, the first quartile, the median, the third quartile, and the maximum. So if you look at the box plot, you can see the median is the middle line, the first and third quartiles are the edges of the box, and the min and the max are the ends of the whiskers. So you can quickly see the 4 quarters of the data, the min and the max, in an easy visual format. Now, a histogram, it looks kind of like a simple bar chart, but the histogram is broken into ranges rather than specific discrete pieces of information. So the height of each bar shows how many fall into each range. So the histogram shows the frequency, how often a result is found for different age groups in this group of people. You can see in this histogram. So the 50 to 60-year-olds have the largest frequency. So there's 5 people. But the 80 to 90-year-old bucket has no members, so that you can easily see the highs and lows of a various group. A scatter plot, or an XY scatter plot, uses dots to represent values for 2 different numeric variables. So the position of each dot is set by its position on the X and Y axes. This is useful when you want to evaluate the relationship between 2 variables. So this scatter plot is tracking the sale of ice cream against the outdoor temperature. Each data point is plotted and we can see relationships in the slope compared to the shape of the graph. And as you can see, as the temperature is going up, the sales of ice cream are going up. So this makes it very easy to see how they relate to each other. The stem and the leaf plot is a way of organizing data into a form that makes it easy to observe the frequency of various types of values. So it's a graph that shows numerical data arranged in order. Every data value is broken into a stem and a leaf. So, for example, for this one, we have 10 data points and they're all decimals. So the stem is the whole number, 2, 3, 4, or 5, and the leaf is the decimal. So we would say stem 2, leaf 3 to be 2.3. And as you can see, this makes it easy for us to see that most of our numbers, half, are actually in the 2s, and then 3s are the second most common, then 4, but there's only the 1 5. So that is the easiest way to break this down, and stem and leaves are really good for that. Now, once the data has been represented graphically using the correct tool, you can draw some conclusions. So we talked about ice cream and temperature, and what trend do you see? As we mentioned, it goes up and to the right. So let's just take a look at this. If the temperature tomorrow is forecasted to be about 21 Celsius, how much ice cream should we expect to sell? And if we were to set a line in this data, what might that line look like? So we would expect to sell about $450 worth of ice cream. That's the points between 20 degrees C and 22 degrees C. And we would expect a straight line with positive slope, and that the hotter it is, the more ice cream is sold. Now, here's a couple of just considerations for choosing your graph type. There's so many choices. How do we pick the right one? So here's some guidelines we could use. So if you have categorical data, you want to use a bar chart, and if you have more than 5 categories, or a pie chart otherwise. If you have nominal data, then use bar charts or histograms, and if your data is discrete, line or area charts if it is continuous. If you want to show a relationship between values, use a scatter plot or a bubble chart or line charts. If you want to compare values, use a pie chart for relative comparison or bar charts for precise. If you want to compare volumes, use an area chart or a bubble chart. And if you want to show trends or patterns in your data, use a line chart, bar chart, or scatter plot. Now, let's talk about probability. Probability is specific values in math, is a measure of how likely something is to occur. Probability problems require you to understand how many ways something can happen and compare it to the number of ways to which you will get your desired result. So let's just start with a classic. If a 6-sided die is rolled, what is the probability that it will be a 3? Well, there's only one result that would give you the desired outcome, the 3, and there are 6 total sides. So the probability of rolling a 3 is 1 out of 6, or a 16.7% chance that you'll get a 3. Now, related to probability is called the counting rule, or the fundamental counting rule, or sometimes called the multiplication principle, to figure out how many outcomes you can have. So this says if I have an event A and I have a second event B, the number of different outcomes is A times B. So let's take a look at this one. A fast food restaurant has a meal special. It's $5 for a drink, a sandwich, a side, and a dessert. So you can see the sandwiches. I got a grilled chicken, I got a veggie burger, and then the sides, I got fries, potato wedges, desserts, and various drinks. So how would I figure out how many different combos I could order? What I'd want to do is I want to count how many options there are. There are 4 kinds of sandwich, 3 types of sides, 2 types of dessert, and 5 types of drink. As we said, it's every number of choices times every other number of choices. So 4 times 3 times 2 times 5, that's 120 possible options that you might order. Now, independence. Probability calculations deal with independence, which is a way of knowing that if one event occurs, it doesn't change the probability of the other event happening. So think about if I have a die and I roll it twice. The first time I roll it, I get a number, and the second time I roll it, it doesn't matter what the first number was. It's the exact same probability, and that's like flipping a coin, or say something like winning the lottery and running out of milk. They're not related. Just because one happens doesn't make the other one more or less likely. But there are also things that are dependent. Say, boarding a plane first and finding a good seat. Those are not independent. You're much more likely to get the seat you want if you get on the plane first. Same thing for robbing a bank and going to jail. You're way more likely to go to jail if you do rob a bank, even if you're not absolutely going to jail. Same with driving a car and getting in a traffic accident. If you never drive a car, you won't get in a traffic accident. So, independent events are calculated separately, but dependent events must be calculated together. So, let's try this. What is the probability that a fair coin lands on heads 4 times in a row? Okay. Then we could talk about, let's say I have 5 blue marbles and 5 red marbles in a bag. You could draw marbles out one at a time without replacing them. And what is the probability that the first 3 marbles will be red? The first one, the fair coin, these are independent tosses. The second one, marbles in a bag, because every time you draw out a marble, the probability is changing because you didn't put the marbles back in. So this is a dependent probability. So for the coins, since they are independent, it's 1/2 times 1/2 times 1/2 times 1/2. There's a 1 out of 2 chance every time you toss it. So there's about a 1 out of 16 or 6% probability that you would get 4 heads in a row. It's not impossible, but it's pretty low. Now, let's talk about this. The first time you draw a red marble, there were 5 red marbles and there were 10 altogether. Well, the next time you want to draw a red, there's only 4 left and there's 9 marbles in the bag. For the third one, there's only 3 red marbles and 8 in the bag. So you have to multiply 5/10 times 4/9 times 3/8. That's 60 over 7,200, or 1 out of 120, or a less than 1% chance that this would happen. Let's talk a little bit about geometric probability. We've done very discrete probability, where there's specific numbers we can calculate. But when you want to look at something geometrically is when success or failure is not specifically known, or you want to look at a region. So think about throwing a dart at a circular dartboard and it's going to land somewhere randomly on it. What is the probability that it lands closer to the center than to the edge? So the set of the outcomes are all the points on the dartboard, which make up an area of pi r squared, where r is the radius of the big circle, right? That's all the places it could hit. Let's continue on. The points that are closer to the center lie within the circle of a radius of r divided by 2. So that's the green circle. So the area of success is pi r over 2 squared, or pi r squared over 4. So now we're going to use our definition of probability. The area of desired outcomes is pi r squared over 4. The area of total outcomes is pi r squared. Pi r squareds cancel. It's 1 over 4. It's a 25% chance that you'll land closer to the center than to the edge. Now, when you have a data set to evaluate, there's a lot of tools you can use to analyze that data set and learn more about that data. So we're going to break it down to two major categories. One is just called central tendency. When you want to figure out where is the general middle or center of the data, this is helpful for doing things like median and mode and mean to just kind of see what's a typical middle value. Now, dispersion is the opposite. It's used to say, well, maybe I have a middle. How close does the data stick to that middle? Is it situated around that central tendency? This would be things like range, deviation, variance, standard deviation, and standard error. So let's just go through some of these central tendency tools. A mean is the average value of the data, and it's calculated by taking the sum of all the parts and dividing by the number of parts. Median is the middle number in a set of values that's been sorted from least to greatest. And if the number of values is even, you average the middle two. So you line them up and you find the middle number. The mode is the value that occurs the most in the set of data. If something occurs more than anything else, that's your mode. And if there's no single number, then the mode is all the values that tie for appearing most. So here's a little example. The heights of 5 people in inches are 56, 66, 63, 72, and 63. We want to know what's the mean, median, and mode height of this group. So the mean would be the average. We're going to sum them up. Because there's 5 people, we divide by 5. And the mean height is 64 inches. The median height, I've rearranged it here where I wrote them in ascending order. Well, I can see that there are five people, and the third one is now the center, and that is 63. That's the median. And the mode, 63 also happens to be the one that occurs the most in the set. So that is also the mode, as well as the median. Now, we have what's called a weighted average. It's very similar to the mean, but a weight or percentage of the whole is applied to each data point. So here's how this is going to go. We're going to multiply each value by its weight. We're going to add those values together and then divide by the sum of the weights. And in a lot of cases, the sum of the weights is 1. It adds up to 100%. So it's the sum of values times individual weight divided by the sum of the weights. So here's a typical example we might want to look at. What would be your grade if your final grade is determined by 3 midterm tests and a final exam? And each midterm is worth 20% and the final exam is 40. So I put it in this little table over here with the assignments. So here's what we're going to do. We're going to multiply each grade by its weight. 90 times 0.2, 85 times 0.2, 84 times 0.2, and 92 times 0.4. We're going to add all those together and then divide by 1. That's the total weight rank of the class. And this tells me that that weighted average is 88.6. So this person's ended up with a high B. Now, let's talk a little bit about more with dispersion and spread tools. So the range is the difference between the max and the minimum values in a set. So in this set we looked at, the highest value is 72, the lowest is 56, so the range is 16. Deviation is the difference between an observed specific value and some other value, typically the mean. This could be positive or negative depending on the spread. So if we know the mean is 64, then 66 is 2 units deviation from the mean. That's something that we can use. Now, variance is deviation squared, and then standard deviation is the square root of variance. And the square root of that variance actually has a lot of interesting tools that we can utilize as well. And then we have just general mathematical diagrams. So a Venn diagram is this picture that represents the outcomes of an experiment or study. It generally has a box that represents the sample space, S. You can see the big box is S, with circles or ovals, and the circles and the ovals represent events. So this Venn diagram says that there are 12 outcomes and how the outcomes relate to each other. So there were 7 outcomes that are within A, 4 outcomes within B. There's 1 outcome that's in both A and B. That's number 6. And 10, 11, and 12 are neither A nor B. But this helps us compare and analyze the different data options. And that is the completion of the Middle School Mathematics Module 5 and the end of the Middle School Praxis Review. We are so glad to have gotten to do this for you. We wish you the very luck on your exam.